Okay, while I'm waiting for Jim to show up, I thought I'd show you one of the pendulums that demonstrates the Earth's rotation. It says it's a Foucault pendulum, it's called, and this one, because of the latitude we're at in Batavia, it advances around 10 degrees per hour. So here's the pendulum you can see already. See down there the path it's traced out? So if we were to come back in a few hours, there's Jim. Hey Jim! Hey Jim. How you doing?
Not bad.
Now are they still using that office over there for part of the Large Hadron Collider?
That's used for monitoring and communicating with detectors and accelerators.
Oh, okay. No way we could get in there though, right? That's off limits?
Not really.
Okay. Not that important anyway. I want to see your stuff anyway. Your stuff is... It's just basic, yeah, it's basically monitors. There's not really anything to see other than what you can see from the outside.
So you're right on a health fair day.
Yeah, I noticed that. I keep
candy or
That's fine. They can keep their candy. I'm not really into that, but I don't see a lot of activity going in there right now anyway.
well, they're not in full operation mode there yet. With
Yeah.
Gliding beams. So,
Oh, that's true. With all the repairs going on and everything, it's not really like it's.
So you're alone. You said you might bring.
Yeah, but the schedule changed for them, so they weren't able to get off. So I'm just pretty much by myself today, but that's okay.
Okay. Well, let's start at the 15th floor, and we'll just give you.
Okay.
You can see most of the facilities from up there.
Yeah, yeah. That's the main thing most people want to see on the video anyway. Okay, we are up on the.
So you can see. Excuse me. Any place you see a pile of dirt, there's a beam line underneath of it, and that's radiation shielding.
Oh, okay.
So going out that way, the one more to the right is out to the old neutrino area, and also to do muon and proton experiments. And the thing on the left there is the meson area where they do now mostly test beams, but there were experiments there before.
So in other words, everybody watching this, if you see those white things that look kind of like power poles or whatever like that, basically.
They are power poles.
Oh, they are power poles? Okay.
Those are Robert Wilson designed pie-shaped.
Boy, he has to have everything good looking, but that's kind of neat in a way to have everything instead of just looking ordinary, have it look good.
Well,
to the right of them are the piles of dirt he's talking about with the neutrino beams,
yeah.
And then to the left, the arch thing that looks like a blue arch is where the meson beam tests are.
Yeah. So the original power poles were wood, and the woodpeckers finally destroyed them. So just a year or two ago, those power poles were replaced, but with a woodpecker-safe material, but this time, but in the same shape.
Okay.
The Robert Wilson design.
Cool.
So here's a map which shows where the various beam lines go. And so the accelerator starts out here. We'll take a look at that with the Cockcroft-Walton low energy accelerator. Gets accelerated through a linear accelerator here into the first stage, the booster ring, and then from the booster ring now out to the main injector, which is this bigger ring, to even higher energy, and then from there finally to the Tevatron ring, which we accelerate then to the highest energies we have on site.
Okay.
And then this area in here is where we produce antiprotons, and they're stored in a ring here. and then fed into the tevatron so that they can collide antiprotons with protons in the tevatron ring.
Okay.
And then these are the old fixed target areas where instead of, in the tevatron, you have beams going in both directions and they meet head on.
Okay.
And you can get the highest energies in that central collision. Out here, it was a fixed target area where you had a stationary target and the beam slams into a target to produce particles. And so,
And the big ring is what does produce your neutrinos that you'd use for your experiment, right?
for my experiment, it's this main injector ring here.
Okay, that's what produces for your experiment.
And it comes out here. This is where our target hall is, actually. It's about here.
Okay.
And then the beam line that creates the neutrinos comes from about here to here. And then this is the near detector location,
Okay.
where we sample the neutrino beam before it heads off to Minnesota. There's another neutrino beam on site operating right now, and it gets its target hall is here, and there's the near detector for it, or well, actually the only detector currently for that beam. That's the mini beam line.
Now, does it produce the same type of neutrinos as you use?
It produces muon neutrinos, but they were looking for the small fraction that might go to electron neutrinos
Okay.
to oscillate. The NUMI line over the long distance to Minnesota looks for the disappearance of muon type neutrinos where they oscillate to taus,
Okay.
tau type neutrinos. But we don't directly observe the tau neutrinos, we just observe the deficit of muon neutrinos.
Okay. Sounds like in this video I'll be getting out the whiteboard a few times and doing little drawings and quick explanations, because first you have to explain to some people what a neutrino is and then that there are different types, so that's okay.
Yes,
That's part of the editing.
Good. I